Assalamu alaikum. We are talking about absorption isotherm experiment, and as I told you that to do the experiment, just to prepare a different concentration of the material you want to let it absorb to another solid material, and I explained that if you prepare a series of different concentration of cadmium and prepare a solid adsorbent of mineral like zeolite, it's a type of mineral has a high CEC and able to absorb. Its absorption capacity is high, so it's easy to calculate the quantity absorbed to the solid substance that by using this equation you put the, the initial concentration equal 10 and the final concentration after shaking is 8 and the final and the weight of adsorbent is 10, so and the final volume is 50, then it will be 10 minus 8 equal 2 multiply 50, final volume is 100 over 10 is the weight will equal to 10 microgram per gram if the first concentration is 10 microgram per liter, the final is 8 microgram per liter, and the final volume is 50 milli, then 10 minus 8 equal 2, and the weight the used weight is 10 grams, then 10 minus 8 multiply 50 over 10 will equal then Q will equal to the 10 microgram per gram. Here microgram per milli, by the way, here microgram per milli. So if you have a first concentration is 10 microgram per milli, the final is 8 microgram per milli, the difference will be 2 microgram per milli. The final volume, if you use a final volume, is 50 for both, so you have to 2 multiply 50 will equal to 100 over 100 microgram over 10 gram. You will obtain 100 over 10 equal 10 microgram per gram. Is this clear? It's easy. It's easy, yes, to calculate the amount of adsorbed to adsorbent by using initial and final concentration on the beaker. So you can then express a curve between the final concentration or the concentration at equilibrium. What mean by at equilibrium? After shaking, this is called the concentration after equilibrium. Then if you plot expressed a curve between C final on x-axis and Q on y-axis, you will have a curve called absorption isotherm curve. Absorption isotherm curve is the absorption isotherm, which is isotherm absorption, means the previous discussion of absorption by making series of concentration with a constant weight of the adsorbent and shake. This called isotherm. Why isotherm? Because it's in constant temperature. We do not use we do not change the temperature. For this called isotherm. The absorption isotherm describe the relationship between the concentration or activity of adsorbate at equilibrium and the quantity of adsorbate on the surface at the constant temperature. How we calculate the adsorbate on the surface? By subtracting the initial concentration and final concentration. The different where it's go to the surface of the adsorbent. Most common way to represent adsorption data suggests but does not confirm absorption mechanism. Absorption process can be described as force shape. When you plot the concentration at equilibrium on x-axis and as Q final or CE at equilibrium, and as I told you, and the quantity of amount absorbed on a y, you will obtain different shape according to the relation between adsorbent and adsorbate. Again, adsorbent means the solid substance which absorb material. The material absorbed to the solid substance called adsorbate. So when I say adsorbate, mean ion, cadmium, for example, or pesticide soluble on water or on a solvent. When I said adsorbent means the solid material. Here should be soil or clay mineral because we are on soil science. But if you go to another department, they may use another substance as adsorbent. Okay, so about adsorbent, if you plot concentration at equilibrium and adsorbed amount microgram per gram, here is microgram per liter or microgram per milli, you will obtain different shape at equilibrium concentration. Here the first shape called L shape. L shape means that what it means? It means that the adsorbent have a high affinity to adsorbate at low concentration, while has a low affinity at high concentration. Why at high concentration? What it means? It means that if you put on the beaker, remember you are putting here on this diagram. If you put 1 gram, all of 1 gram will be absorbed to the, because it's a low amount. 5 gram will be absorbed. When you approach to 100 millimole, sorry, if you are putting here 1 millimolar or microgram per milli, let us use microgram per milli is better. Microgram per milli. So if you use when 1 microgram per milli, then all contaminant will be absorbed. Why? Because you have a lot of empty site can be absorbed this material on this on sorbent. When you increase the concentration of the contaminant or the absorbate, the ability of the adsorbent to absorb more contaminant will be decreased. Why decrease? Because all sites are full with contaminant. So this what L shape is describing, that in low concentrations the affinity is high and start to be low. In S shape the affinity is low and increase and then low. This S shape. The L shape is called Langmuir. We will discuss this, more famous shape. L shape is Langmuir. Cooperative absorption, stronger adsorbent and adsorbate interaction. Here is because the bonding takes some time and then the absorption strong affinity increases and decreases. C shape means that called constant partitioning, constant relative affinity of adsorbent for absorptive, usually non-polar compound. It means that the concentration of adsorbate has no relation to the ability, has no effect to the ability of adsorbent for absorption. A constant partitioning, or a constant affinity. H shape means that there is, again, we are plotting absorption isotherm. You have, and if you plot the concentration at equilibrium and the quantity of material adsorbed to adsorbate, you will get four most popular shape: L curve, S curve, C curve, and H curve. H curve means high affinity. High affinity or very strong adsorbate-adsorbent interaction. There is a very strong interaction between adsorbent and adsorbate. Let us together go through some two famous empirical absorption models, empirical and theoretical absorption models. These two models called Freundlich and Langmuir equation. The Freundlich model is an empirical equation used to describe the adsorption of gas and liquid to the solid phase. Actually, these two models are widely used in soil chemistry. Is there other models? Yes, there is, but these two models are most popular in soil chemistry. What the benefit of these models in absorption isotherm? This model help us to make an interpretation of the relation between absorbent and absorbate, and also you can able to predict the bonding energy between absorbent and adsorbate. On Langmuir, you can also calculate the maximum absorption if you are going to plot the curve like previously. So to make an interpretation of absorption isotherm and the ability of adsorbent to absorb the ability of adsorbent to absorb more contaminant, you can use this equation to help you do that. Okay.